Welcome to Maths for All. I'm Aisling Flynn. This is Higher Level. And in this video we're going to look at the line and the perpendicular distance. That's the perpendicular distance from a given point to a given line. Okay, and we have a formula to describe that. If the point in question is x1, y1, then the perpendicular distance, that's the red distance d, to a line such as the blue line there, which has the form of ax plus by plus c equals 0, well, the distance can be calculated by the formula given here. Okay, so the values of a, b and c come from the equation of the line. A is the x coefficient, b is the y coefficient, and c is the constant term. Okay, and here you can see those in the formula: a, b and c, and a squared plus b squared underneath. And the coordinates of the point you're given is x1 and y1, and you see those here in the formula: x1 and y1. Okay, and it gives the perpendicular distance d. Perpendicular is when you draw a line that meets from your given point that meets the blue line at 90 degrees. Okay, so let's put that formula to practice. If you need to find it on the day of an exam or while you're doing your exercises, you'll find it on the second page of coordinate geometry, which is page 19, and the second page of the line before you come to the circle. And here we have it: distance from x1, y1 to the line ax plus by plus c equals 0. And here is our formula. Let's recall that these two straight bars here are the modulus, or it means the magnitude or size of. It means the absolute value. You're taking the positive value of whatever's between those two lines. So let's put it into practice. Okay, here's a question. The vertices of a triangle are the points A, B and C. The coordinates are given there, and it is shown in the diagram to the right. Part 1 of the question says, find the length of the perpendicular from A to BC. So AN. So we're looking for this distance here, the distance of this perpendicular line. So from the point, so A is our point, so this is 1, 2, that's my x1, y1, to the line BC. Okay, so that's my line, and you'll notice, so the line usually takes the form of ax plus by plus c equals 0, and you'll notice that we are not given the equation of that line. So that will be our first task. Okay, before we can complete the formula for the perpendicular distance, which is here from your formula books, before we can fill this out, we need the equation of that line BC. So that's our first task. Okay, and to do that we'll use the equation of the line formula, which you're familiar with now. You can find it in the formula books, page 18. Sorry, it's x minus x1. Okay, to complete this equation we need to know a point on BC, which we have. We'll use B, which is 3, 1, but we also need to know the slope. So actually we have an additional task here. The slope of BC, the slope form is y2 minus y1 over x2 minus x1. Now it doesn't matter which is point 1 or 2. Let's take C as being 2. So this is my x2, y2. This is my x1, y1 for slope. So we'll start with y2. So minus 2 minus 1. That's from point B. Minus 1 from point C. Minus 3 from point B. Okay, so we get minus 3 over minus 4, which is 3 over 4. Okay, still finding the equation of BC. So let's use our value for slope. So we have y minus, now I'm going to insert the coordinates of point B here. So y minus 1 equals 3/4 times x minus 3. Okay, let's multiply here to remove the fraction, and let's give our equation in the required form. So we're going to multiply left and right by 4. Okay, so on the left I'm going to have 4y minus 4, and on the right it will 4 divided by 4 will give us 1, so that goes. And we have 3 times the bracket, so we'll have 3x minus 9. Okay, now we want ax plus by plus c equals 0, so we want to lead with our x. So I'm going to bring everything to the right hand side and leave nothing on the left. So we'll have 3x. We're taking 4y from both sides. We have minus 9 already on the right, and we're going to add 4 to both sides. Okay, and final tidying up of that, we'll have 3x minus 4y minus 5 equals 0. So this is the equation of BC, which we're going to use to get our perpendicular distance. Okay, so perpendicular distance, we're using our formula, and we're using the equation of BC. So if you wish, make a list. So from the equation of BC, we see that A is the x coefficient is 3, B, which is the y coefficient, is minus 4, and C, which is the constant, is minus 5, and our x1, y1, we already said would be point A, which is 1 and comma 2. Okay, let's input all those values to get the distance AN, which we'll call for short D for distance. Let's input the values. So it's A, which is 3 times x1, which is 1, plus B, which is minus 4, I'm just going to use brackets there, minus 4 times y1, which is 2, minus 5, which was C, all divided by A squared, so 3 squared plus B squared minus 4 squared. Okay, so let's simplify as much as we can. So within the modulus bars we have 3 minus 8 minus 5. Under the square root we'll have 9 plus 16. Okay, on the top line we'll get, within the bars we get minus 10, and underneath we'll have the square root of 25. Okay, so as previously discussed, we'll take the positive value of what's in the modulus bars. Okay, so we'll get plus 10 over the square root of 25 is 5, so that distance there, which is otherwise called AN, is 10 divided by 5, which is 2. Okay, so that's the first part of the question. Now the second part of the question says hence, so hence means use what you've just done, find the area of the triangle ABC. Now we have coordinate geometry ways of doing that, but it said hence, so we won't follow that route. We now know that the distance from A to N is 2. Okay, and we know it's a perpendicular distance, and the most straightforward way for getting the area of a triangle is half the base by the perpendicular height. So now from part 1 we have the perpendicular height, which is 2. What we don't have is the length of our base. That would be the length of BC. So of BC. Now how would we do that? Well, we do the distance formula, which will tell us that BC is equal to the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. So that's the distance or length formula from your formula books. Okay, so we're using points B, we'll call that x1, y1, and point C, x2, y2. Okay, it actually doesn't matter which one is which. Now, so for x2, we'll get minus 1, minus 3 to be squared, plus minus 2, minus 1 to be squared, which is square root of minus 4 squared, plus minus 3 squared, which is square root of 16 plus 9, familiar numbers again, which is the square root of 25. So the length of BC is 5 units. Okay, but that wasn't the question. The question said the area of the triangle, which is half the base by the width, so it'll be half times 5, or the base by the perpendicular height, excuse me, and we found that in the previous question, which is 2, so it's half of 10. So the area of the triangle is 5 square units. So a bit to take in there. Your best bet is to go take a blank page, go back to the initial question and try do it yourself, and then compare. So here's another question involving the perpendicular distance. Find the equation of two lines that are parallel to the line x minus 2y equals 5 and a distance of 3 root 5 from it. So that line mentioned is shown here on the graph. We could write it also as x minus 2y minus 5 equals 0. That's taking 5 from both sides. Okay, we may need it in this format. And so it's always useful to sketch to try and picture what you're aiming towards. Okay, so it says find the equation of two lines that are parallel. So parallel means the same slope, and a distance of 3 root 5 from it. Okay, so 3 root 5 is roughly, let's check here with the calculator, 3 root 5 in decimal is almost 7 units away from it. Okay, so there's going to be two lines that are nearly 7 units away from this green line. One will be above it and one will be below it. So that's the red and the blue lines shown there. Okay, so if you've an idea of what you're looking for, it sometimes helps. Okay, so how to go about this? And to use it's something to do with perpendicular distance, so I'm going to start by writing down that formula first. Okay, now how are we going to approach this? We're going to look for the equations of those two lines, the red one and the blue one. Okay, now we do have some idea of what they may look like. Okay, if they have the same slope, they're going to have the same ratio of x's to y's. So the parallel lines will have the form, they're going to have the same ratio of x to y, so x minus 2y, but the only thing that will be different is the constant part. So they're shifted up or down the graph. So I replace that with c, which is unknown, equals to 0. So they both have that form, but they'll have different c's. Okay, so we expect to get two answers out of this work. Alright, now we do know the distance is 3 root 5. And what else do we need to know for our formula here? We need a point. Okay, now if we're using this here as our equation, this will be our ax plus by plus c equals 0. Okay, if we're using that for our equation, well, the point must be on the green line somewhere. Okay, so we need a point on the green line. The easiest one, because I've drawn it here, right? How would you get that? When y equals 1, or when y equals 0, we put it into our equation of the line, we get x minus 2 times 0 minus 5 equals 0. We get x minus 5 equals 0, we get x equals 5. So that's the point 5, 0, and that's on the green line. We know the perpendicular distance from this point is 3 root 5, and we're trying to find the equation of this ax plus by plus c equals 0, and we're doing the same for the blue line. Okay, we're trying to find its equation, and we know that that distance there is 3 root 5. And in actual fact, you could use any point along the green line and it will give you the same distance, okay? But 5, 0 are easy numbers to work with. Alright, so I'll just enclose that to give us more space. Okay, so we're going to use our perpendicular distance formula and put in what we know, and hopefully we'll get out what we need. So 3 root 5 was the distance, equals 2. Now, following this here, our a is 1 times, this is my point is x1, y1, so it'll be 1 times 5, okay, and it'll be plus b, which is minus 2 times 0, plus c, we still don't know that, okay, and we'll divide that all by the square root of a squared, which is 1 squared, plus b squared, which is minus 2 squared. Okay, so now what you see is not very tidy, but it is an equation. There's only one unknown, which is c, so we should be able to solve it. Okay, so 3 root 5, let's simplify everywhere first. We get 5, now 2 zeros is nothing, so 5 plus c in the modulus bar over the square root of 1 plus 4. Okay, so we get 3 root 5 equal to the modulus of 5 plus c. Okay, and divided by the square root of 5. I'm going to multiply both sides by the square root of 5 now, my next step. So I get 3, we'll write it out long, root 5 by root 5 will be equal to the absolute value of 5 plus c. So when you multiply by root 5 on the right, then it gives 1. So what is root 5 by root 5? Well, it's 5. And what's 3 times 5? It's 15. Okay, is equal to 5 plus c. Alright. Okay, nearly there. So remember what the modulus bars mean. It means take the absolute value, which is the positive value of. So the positive value of that is equal to 15. So we have two scenarios. 5 plus c could have been equal to 15, or 5 plus c could have been equal to minus 15. And this is how we arrive at the two different answers for the two different lines. Okay, so here we get c equals 15 minus 5, so c is 10. And here we get c equals minus 15 minus 5, so we get minus 20. And so my two lines, so the higher one will be, the red one will be x minus 2y plus 10 equals 0, and the blue one will be x minus 2y minus 20 equals 0. And there's the equation of the two lines parallel to the one given in the question, but a distance of 3 root 5 away. Here's another question on perpendicular distance. Find the equations of the two lines that pass through the point 3, 2 and are at a distance of root 5 from the point minus 2, minus 3. So definitely in this case, I'd advise that you sketch a graph just to understand what you're looking for. So here's a graph with the 2 points mentioned, and they're plotted, 3, 2, minus 2, minus 3. So two lines must go through 3, 2, and they're a distance away from minus 2, minus 3. So they're going to look something like this, okay, where the two lines are a distance of minus root 5, or sorry, of root 5 away from the two lines, okay, and they're at 90 degrees, those two lines I've just drawn. Okay, so that's what we're looking for. So we're looking for equations of lines, so the equation of the orange and the equation of the blue line. Okay, and obviously this will be our point for the distance formula. Okay, so I'm just going to transcribe our distance formula here, and we'll see do we have what we need to complete. Okay, so we have the point which is minus 2 minus 3 for this formula. That's the x1, y1. What we don't have is the equation of the line, or lines in this case. There's two of them. So we have to come up with the equation of those lines. So I'm going to write down the formula for the equation of a line. And we have some information, but not all information needed to do this. And we do have a point, 3, 2, that belongs to both lines, so we can use that in this case for this particular formula as our x1, y1. What we do not have, however, is the slope, and currently we can't calculate it because we don't know the values of another point on either of the lines. So let's go with what we have and see what we can work out. So y minus 2 is equal to m times x minus 3. Y minus 2 is equal to mx minus 3m, and I'm going to finish by rearranging this in the format that we need, which would be ax plus by plus c equals 0, to use this with our distance formula. So I'm going to bring everything to the right hand side because it's leading with x. So we have mx, I'm going to take y from both sides. I have minus 3m, and I'm going to add 2 to both sides. Okay, so here's my mx minus y minus 3m plus 2 equals to 0. Here's my equation of the line for use with the distance formula. Now, doing some quick comparisons, the values for the formula which I'm going to use, a equals m, okay, it's not ideal but we'll figure that out, b equals minus 1, and c equals minus 3m plus 2. And as I said already, we have our point for the distance formula. So, and what else do we have actually? Yet we know the value of d is root 5. Okay, so we're going to fill in the distance formula. So instead of d, I have root 5 equals a is m times x1 is minus 2, plus b, well, b is minus 1 times y1, which is minus 3, and then c is minus 3m plus 2, and that all is to be divided by a squared, which is m squared, plus b squared, which is minus 1 squared. Okay, now have a look here. We have an equation. We have one variable that's unknown, m, so we should be able to solve it. Now let's tidy up and see where we go from here. So I'm going to simplify what's within the modulus bars. I have minus 2m plus 3 minus 3m plus 2, all to be divided by m squared plus 1. Okay, I'm going to simplify, move to the right here, I'm going to simplify what's within the modulus bars, and I get minus 5m plus 5 over square root of m squared plus 1, and I'm going to multiply now at this stage by the square root of m squared plus 1 on both sides. Okay, so I get on the left root 5 root m squared plus 1 equal to, and it disappears on the right because anything divided by itself is 1. Okay, and I'm going to bring this line forward onto the next slide. Okay, so continuing from where we were, I'm going to multiply the two roots here, and I get 5m squared plus 5 equals to what we had on the right. Now, at this stage, we have our modulus bars. Recall that that says that the absolute value of what's inside those brackets could be, or the absolute value would be positive, but what's inside could be positive or negative. So to ensure it comes out positive, we're going to square both sides, and in doing so, that will remove the square root sign as well. Okay, so squaring a square root, what we get is 5m squared plus 5 equal to, now to square this we multiply it by itself, minus 5m plus 5 by minus 5m plus 5, and we get 5m squared plus 5 equals 2. Now squaring this, start with your minus 5, I get plus 25m squared minus 25m. Then going to the plus 5, I get another minus 25m plus 25. Next line, simplify the right hand side, I get 25m squared minus 50m plus 25. And now we have the makings of a quadratic equation where the variable is m and we can solve for it. Okay, now to solve your quadratic we need everything together on one side and put it equal to 0. So I'm going to take 5m squared from both sides, and I'm going to take 5 from both sides. And so what we are left with is 20m squared minus 50m plus 20 is equal to 0. Okay, there's our quadratic. We can make life a little easier by dividing across the board by 10. Get rid of those zeros. We have 2m squared minus 5m plus 2 equals 0. And now let's solve. Okay, so to solve you have a choice of factorizing or using your minus b quadratic formula. Numbers are small, so factorizing should be easily done. So 2m squared is gotten by 2m by m. 2 is gotten by 2 times 1, and to make 5 we'll put 2 here, makes 4, and 1 makes 1, and we need them to be negative to get a minus 5. And now let's put each factor equal to 0. This will give me m equals plus 1 over 2, a half, and this one here will give me m equals 2. Alright, so how have we gotten closer to our answer? Well, now we know that the slope of our two lines, okay, one will have slope 2, and you can see that, that's the blue one here, and the orange one has slope of a half. Okay, so we know their slopes, we know a point that belongs on each line, so you use your equation of a line formula. Okay, for each one. So we'll go with the orange line first, or line 1 if you prefer. So we'll get y minus 2 equals to a half times x minus 3. Okay, multiply both sides by 2. I get 2y minus 4 equals 2. Oh, that would get rid of that 2. So I'd have 1 times my bracket, x minus 3. And just for convention, let's write it in the form of the line that we're used to. Ax plus by plus c equals 0. I'm going to move everything over to be with my x here. So I'll have x minus 2y minus 3 plus 4 equals 0. I get x minus 2y plus 1 equals 0. So that's one line. Okay, and now we'll repeat that for the blue line. Okay, so we'll have the same point as before, but the slope is different, 2 times x minus 3. We get y minus 2 equals 2x minus 6. Again, I'm going to write it conventionally and move everything to be with the 2x on one side. So 2x minus y, we had minus 6, and then plus 2 equals to 0. I get 2x minus y minus 4 equals to 0. And there I have answered the question. Okay, so practice makes perfect. Try the question from scratch yourself and see can you go through the logical steps.